Here, today, in today's lecture of this chapter called Motion in the Plane, we are going to talk about addition of vectors using graphical method. So let us assume that let us take two vectors A and B, right? Now remember that a vector has two important things. One is its modulus, another is its direction, right? You call magnitude and direction, no? So the magnitude is represented by in the graphical method as the length of the your vector, and direction is obviously the direction of the arrow, right? So or head of the arrow, you can say. So let us take now a summation. So A plus B. So A, let's take A is represented by this. So you start with the tail and go as head. A, you can call it P, Q and R. Right? Now as you're starting from the A to B, B will go like this. Right? You can call it R, right? Then the resulting vector will be basically tail of A to head of B, right? This represents as R vector, which is nothing but resultant vector as A plus B summation, right? So this is also called the triangle law of summation, right? Triangle law of vector addition or parallelogram law of vector addition. Right? So these are some of the laws, right? Which are used for vector addition and which we are following here. Now, this was the simple result. You just took the head of the A and in this order, and then from head of the A to here, just added the tail of B, and from tail of head of B, you just added a vector with its head at B and the head of B and tail at the head of tail at the tail of A, right? So this is vector addition. Now let us take some simple properties. The first property is that it is commutative in the nature. Vector addition. Addition is commutative in nature. Right? So vector addition is commutative in nature. It means that A plus B equals to B plus C for two given vectors. Right? So you simply take it like this. What is B plus A? So represent vector R S and T, S T U. So B is there, and then A is there, right? Then R will be something like this. Resultant vector, right? So you can see the resultant vector independent of the choice order of addition remains same, right? R equals to A plus B, R equals to A plus B. Sorry, this is B plus A. So R equals to B plus A remains same as R equals to A plus B, right? Now the another important property is that vector addition is associative. associative in the nature, which says that A plus B plus C is same as A plus B plus C. Right? So this is something we need to remember. A plus B plus C equals to A plus B plus C. Right? Now let us try to understand it. What is this? This is associative law. So to understand it, we'll use another graphical method. Let us take A and then B and then their resultant as A plus B. Now let us take C, right, as this, and then this as B plus C, right? B plus C. So this is C and then this is C. Right? This is B plus C. Right? This is A plus B. Now, if you take this vector, what does it represent? What does it represents? This is A plus B and this is C. So this represents A plus B plus C. Right? So A plus B first, right? And then C from that end, and then C. Right? This is A plus B plus C. Now, if you see from this end, what does it get? B plus C, right? Plus A. B plus C plus A. So what does it represent? A plus B plus C. So it represents A plus B plus C. If you take this one and then sum with this, it will give you A plus B plus C, giving you A plus B plus C. And if you take this one, A plus B plus C, giving you A plus B plus C. So it gives you two which are equal to each other, right? So this is how associative law follows. Right? So this is what we call the associative law of vector addition. Now let us go to another important point, which we call the null vectors. So what are the null vectors? Null vectors are those vectors whose mod is 0. Mod A is 0. Right? So it means that if you have a, let us take, like you had a graph and here the point was P and P dash. Right? Now we went from P to P dash and then came back to P to P dash. Then our resultant will be PP dash plus, minus P dash P. Right? P dash P vector. If you sum it, P dash P dash P. P to P dash has this direction and P to P dash to P has this direction. So this will be giving you 0 vector. This vector, which has magnitude as 0, is called null vector. Now, addition of null vector to any vector has no change in the mod or direction of the vector, right? Yeah, but its multiplication with any of the vector will certainly give you 0, a null vector. And its multiplication with the scalar also will give you null vector. So these are some of the properties of null vector and the vector addition which we have discussed right here, right? So just you can go through this vector addition, and if you have any problem, just write in the comment section. We will look into it, right? Now let us discuss the subsection of vectors. using graphical method. Right? So how we will do that? So subtraction is nothing but addition with a vector with a negative sign. Right? A minus B is equivalent to writing it as A plus 1 minus of B. Right? A and B is the direction opposite to that of. So to represent a vector, compare, just take A, right? Just take A as a vector, right? And then take B as another vector. Then resultant vector is R, which is A plus B. Now in this case, if you want to take, then minus B will be something like this, right? And then this will be resultant R, which is A minus, right? So this is A plus B, and this is A minus B. If you change the direction of the arrow changes, and then the resultant vector like this. So this is called the subtraction of vectors using graphical method. Simple, just the one which you are using for the direction which you are using for addition, you will just reverse it to add it for, use it for the subtraction, right? Now let us go to resolution of vectors, breaking vectors into more other component of vectors, right? So what is the resolution of vectors? Let us take a vector A and B. A and B are two vectors. And then there is another vector, and capital A is another vector. Right? Now you want to find capital A in terms of A and B, right? So what exactly you will do, that A is something like this, whereas A is like this and B is like this. Let us assume that, or you can write in this way, A and B, right? Now you want to express A in terms of A, small a and small b. So how you will write it? You will write it on A, first you will draw starting from here, or the origin point, you will draw a line which is parallel to this vector A, right? And which you will call it as lambda times A. So it will be like A is lambda times A, and similarly AB will be some lambda and mu times B, right? You can take its component which is parallel along B. So the vector A can be represented as AA plus AB, which is lambda times A plus mu times B. So mu, you can write it mu times B. Right? So this is a vector resolution, a simple way. Now let us take it to more particular cases. This is a general case. Now let us specify A and B. and their directions, and then take a particular vector, subvector A, and break it into, right? So let us take an example of a vector. A is there. Now, how does the vector is represented? If you want to represent into A, basically write it into its component along a different direction. It is nothing but the mod of the vector A multiplied by the unit vector along that direction, right? So if you want to represent a vector along a particular direction, so you will be writing it in terms of unit vectors, right? Where n can be n1, n2, n3 like that, right? And where mod is a1, a2, a3 like that, right? So you can write it ai, ni like that, right? So this is there. So A is represented in this way, where n is nothing but the vector A divided by mod of vector A, and it is unit. It has modulus as n, as a modulus of unity, and it represents the direction. And direction, right? So it's the unit modulus and represent direction. And now remember that these ni's are perpendicular to each other. Perpendicular to each other for each I. Right? In general. Now to understand it, how this happens, we'll take a simple example of your Cartesian coordinate, 2D vector in a 2D plane, right? So let us take a vector. Remember that unit vectors in Cartesian coordinate are represented by I, J, and K cap vectors. Now this K cap represents the unit vector. That is different from whereas a vector which is not a unit vector will have an arrow, right? This is a unit vector. Cap represents the unit vector, right? So where I is along x direction, J along y direction, and K along z direction, right? So no confusion should be there. So I, J, and K, x, y, and z component, right? So this is there. Now, if you let us take a 2D example of a 2D case. The vector is there, A, and x and y is there. It is having unit vectors as I and j cap. Now A is a vector. Now you want to represent A in terms of I and j, right? A component along x and y. So how A can be written as? A can be written as ax I cap plus ay j cap. Remember that Ax is not a vector, Ay is not a vector, other than they are components with magnitude. I and j are vectors, right? Not vectors, right? So now, so what is the now to calculate it? So more specifically, Ax and Ay, how do we define it? We will assume that this vector makes an angle theta with the x-axis, right? So when if it is the case, then you will break A along the x direction and y direction. It will be AX will be A cos theta and AY will be A sin theta, right? So A will be A cos theta I cap plus A sin theta, right? Now let us calculate the resultant vector modulus it has. So modulus of it will be AX square plus AY square, right? Because I and J are perpendicular, so their dot product will be 0. So this will be giving you A square cos square theta plus A square sin square theta, right? Which will obviously give you A. So this is the resultant vector. Now, to find this angle tan theta, it will be AY by AX, right? AY divided by AX. So what is AY? It is your A sin theta divided by A cos theta, right? So this is these are some of the formulas which you remember. Resultant vector in 2D and its direction with x-axis, right? Or you can say the slope. So this is all we have about resolution of vectors in 2D in Cartesian coordinates. Now let us go to the 3D. In 3D case, what will happen? In 3 dimensions, where A will go to AX I cap plus AY J cap plus AZ K cap, right? So in this case, if you take the mod of A, it will give you AX square plus AY square plus AZ square, right? You can assume in this case as angle as alpha, beta and gamma. Alpha, beta and gamma, right? X, Y and Z, I, J and K, right? So this is one representation, and the angles also, depending upon which angle you want to calculate, it can be found, right? So A is usually represented as A cos alpha I cap plus A cos beta G cap, A cos gamma K cap, or like that, and then breaking it into, right, or similar thing. So this is your resolution of the vectors, which we have given you some idea of. Now let us go to other important thing, that summation of vectors, or how does the summation, addition and subtraction of vectors work. Now if you take A as a vector as some A1 I cap plus A2 J cap, and B as a vector as A3 I cap plus A4 J cap, then A plus B, which is a resultant vector, will give you as A1 I cap plus A2 J cap plus A3 I cap plus A4 J cap. Now I will sum up and J will sum up. So A1 plus A3 I cap plus A2 plus A4 J cap. So this is simple summation. and the same will work for the subtraction also. Right? So a minus b will be simply a1 minus a3 I cap plus a2 minus a4 j cap. So these are some of the laws which everyone should remember. How the summation of and addition and subtraction. Right? Other vector groups. Right? These are some simple things. Now we will come up with more results in the next lecture.